Okay, so now the next topic we are going to see is the PWM mode. Okay, so it is known as pulse width modulation. So we want to suppose in some cases we want to generate an analog output. Okay, practically it is not possible. Okay, so as your controller only understand the digital signals and it is designed to actually understand the digital signals. So in that case, what we are going to do, we are going to generate analog signals on the basis of turn on and off time of a digital signal. Okay. Now in pulse width modulation, let's consider you're having a fan at home. Okay, the ceiling fan is there. Now what I want to do, I want to control its speed. Okay, suppose what I'm doing, I'm turning on and off the button. Okay. Suppose for 1 second I'm keeping the button on, for 4 seconds I'm keeping it off, and I'm repeating this process continuously. What will happen? The fan will gain a certain speed. Okay. Now if I increase the on time of the button, okay, I instead of 4 seconds, if from 4 seconds for 2 seconds I'm keeping the button on and for 2 seconds I'm keeping it off. Okay, so it will gain 50% of its speed. Okay, now what I'm going to do, from 4 seconds I am turning on the keeping on the button for 3 seconds and I am turning it off for 1 second. So it might reach up to 75% of its total speed, and if we continuously keep it on, it will gain its maximum speed. So here what we are doing, we are manually turning on and off the button for fraction of seconds. But in case of fan, you can feel that the output is analogous. Okay. So here there are few terms that we have to keep in mind. First one is your duty cycle. Okay, duty cycle is the total percentage, okay, of on time. Okay, so let's see how you can calculate the duty cycle in this case. So here is your duty cycle. The formula for duty cycle is your on time divided by your total time. Means let's consider this is the maximum marks you can get. Okay, let's consider this part is the maximum marks you can get divided by the, sorry, this part is your maximum marks and this is the marks you have got and multiplied by 100. This is how we calculate the duty cycle. It's calculated in the percentage form. So here the on time of the pulse and this is the off time of a pulse. Okay, so there are few more factors that will help us during the calculation. Okay, now let's see a few hardware parts. Okay, so in hardware we have to set the range for your duty cycle. Okay, so here what I am limiting it to 0 to 255. Now actually practically this range can go from 0 to 65536 because the resolution of your PWM in STM32 is 16 bit, that is 2 raised to 16, so it can go up to 65536. Okay, now why we are using it in only limiting it to 255? Because in practical life we are just going to control the motor speed and we are going to see the results on the LED while testing the PWM. If we are using 25536, that is complete 16-bit resolution, so in that case our human eyes are not going to recognize the dimming or the change in the intensity of the light. Okay, now for storing this highest value, so for that we are going to use ARR, auto reload resistor. Okay, now here this is your on time. Okay, this is stored in your CCR, control and capture and control resistor. Okay, so this value is continuously compared with this value 255. Okay, yes, suppose it is having 128 number. Let's go to the next page. Okay, here what we are doing, suppose your CCR, this is on time, CCR contains the on time. Suppose the on time is 128. So what will happen at 0, the pulse will turn on, and from at 128 it is going to turn off. Okay, so 50% of now, if you divide 256 by 2, that will be 128. Okay, so for 50% of time it is going to remain on, and after that it is going to turn off. Now there are few more calculation regarding to the clock also, so that we are going to see during our practical session and coding time. Okay, so let's jump to the coding. Okay, now for the project, let's close our old project that was regarding our LDR. So let's close the project. Now file, new project, SCM32 project. So we're having the network issue a little bit. So